So now in this video I got a diagram I made a long time ago, and every once in a while my printer doesn't print black very well, so it looks kind of gray. But any case, what we got here, we got three different circuits where my goal was about 9 milliamps of current. So let's first start off with the simplest one. So we got a green LED, and that's what I want to put about 9 milliamps of current through. And with 12 volts at the supply, green LEDs, they drop about 3 volts. So out of that 12 volts, we got about 9 volts left over right there. And I did the math down there for the current we can expect. About 9 milliamps of current. And usually when I got 12 volts, I use a 1000 ohm resistor to protect either a blue or a green LED. This green LED is really bright though. Hurts my eyes to look at it, even with it in the background. So about 9 milliamps of current. This is close enough. This is not as accurate as a multimeter. And odds are we are slightly below 9 milliamps of current. You know, like 8, something close to 9. But there we go. That's one LED, and that resistor was fairly warm. Now, the next resistor won't be as warm. We're going to put 2 LEDs in series right there. It's going to have the same amount of current across it, going through it. I mean, the resistor, remember, current always goes through, voltage goes across. So it'll have a lower voltage across it. Try to plug that in without looking. I was also using my thumb to block it from my eye, which was in a different spot than the camera, but it had the same effect right there on camera. The LEDs didn't flash the camera, but who cares? The camera can take it. So there we go. We got about the same exact amount of current. So the way I selected this resistor, I didn't just keep grabbing different resistors until I got 9 milliamps of current. I did the math. So 2 green LEDs, they're in series. They're both dropping about 3 volts. And they got a forward voltage of about 3 volts. Each one's dropping about 3 volts. And when it comes to that drop, it's that resistor. So 3 volts dropped, total of 6 volts dropped. So we got 6 volts left over. 12 minus 6 equals 6. So we have 6 volts. We figured that out. Our desired current is 0.09 amps, 9 milliamps of current. So 667 ohm resistor. I don't have one of those. 680 is my closest one, and it works just fine. You can see we got about 9 milliamps of current right there. Probably pretty close to 9 milliamps of current. Now, we are going to make 3 times the voltage drop of our original circuit. So we'll plug that in up there if it will fit. There we go. Don't force it in. That can bend the metal. Clip that's in there, and maybe make it so it never accepts a component again, or so that it doesn't really grip any components very well. But yeah, we got all 3 lit up. It's easy to go on the wrong row. If you only see 2 lit up, you know, you got to go up 1 more row, or you miswired otherwise. But yeah, there we go. We got 3 LEDs lit up, and we wanted about 9 milliamps of current, so I used a 330 ohm resistor. Again, the green LEDs are dropping about 3 volts each for a total of 9 volts. Out of that 12 volts, we got 3 volts left over across the resistor. And that's when we do that math. We know we got 3 volts, and our desired current gives us the resistance we want. So it's close enough to a 330, pretty close there. But again, power supply says 8 milliamps of current, but again, it's probably a little bit higher. It's probably closer to 9 milliamps of current, but even if it isn't, the LEDs are bright enough where 9 to 8 milliamps of current probably doesn't make too big of a difference. So green LEDs, blue LEDs, you can light them up pretty well with just like 2 milliamps of current. Now, with all of these circuits, each one of them has the same amount of power it's using, 12 volts, and according to this, 8 milliamps of current. But whatever, they're all basically the same amount of total power they're using, but here we're getting 3 times as much light as we were over there. Here we got 3 times as much heat waste as we have over there. So technically this is more efficient. We're getting more use, light, out of it than waste, heat, right there. So, in any case, that's about it. Just came across this diagram I made a long time ago and thought it would be a good time to make another video on it. So, mostly for those absolute beginners. Anybody that's done electronics for a fair amount of time should already know this. So, in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.